and welcome back to the studio. My name, of course, is Ollie, and today we are looking at another one-day CAD. Similar to the last format, I'm going to do a replica of one of the works that Adam Savage recently did on his one-day builds, because I found it quite fun and challenging. So, roughly 3 weeks ago, Adam Savage did a mini NASA retro reflector. So after a little bit of research, I think we can do our own. So, unlike Adam, I'm going to be 3D printing everything in this project, and so I need to draw everything, even right down to the retro reflective prism. So, after a little bit of research from the website, which I shall pop up now, I found out some good information. So, the key bits for me were that with a diameter of 1 inch, which is 25.4, the overall height of the prism would be roughly 22 mil. So, I'm going to trust the website, so let's extrude up to 22 mil, and that gives me the basic form. Now, I'm not actually sure. I should have done a bit more research, and I could have been a bit more informed. I presume these are machined from a solid stock and then polished. I imagine the faces of the 90 degrees are machined off and then polished. I'm not sure. If you know, drop a comment in light below. I'd be really fascinated to know. But what I'm going to do now is essentially cut away the faces to form the 3 sides of the cube that is formed on the top. Now, Adam mentioned a crucial detail in this, that they are 90 degrees face to face. So I'm going to start a 2D sketch on the XY plane. I'm going to slice the graphics so we're halfway through it, so it's a bit clearer. And I'm going to draw a line from the top because it cuts towards a peak. We put 25 mil in because I can see it's over the body. And then, because it's roughly 35, I'm going to do 90 degrees minus 35. So it's a 55 degree cut, but 35 this way. And that's what I'm going to use as my starting point. Now, I'm going to set that to a construction line because it's referenced the top line of the prism. Now, the reason I've drawn this line is so that I can create a plane. Now, if I select and highlight the XY plane again, I'm going to select the line, and it's going to give me a plane 90 degrees to that. So I'm going to accept that because that's the plane that I want. And if I trim that, I then get my first face. But what I need to do is create three faces. I'm going to create a central axis, and then I'm going to use a circular pattern of this feature around this axis, and I want 3. And that is my 3 cuts that I need to do. Now, at this point, I can hide this sketch because there's quite a bit of a mess going on, and I can hide the central axis if I want, but I'm not going to at this point. And then I'm going to use the split tool. At this point, it asks me to select what is the tool of split. So that's going to be the plane, and the faces is going to be the working solid. Now, interestingly, for some reason by default it hides the behavior, so I'm just going to hit that solid selection button or behavior button, which keeps this here, and it gives me the option to keep both sides, trim one side or the other. Now, the arrow direction is indicating the side which I'm trimming. So in this case, I want to trim to the top right of my screen. So I'm going to hit OK. First trim done. Excellent. Then I just need to expand in my model directory and then go through the same process. Although I don't need to because I can select objects, but I just like to do it. Good practice. It's automatically, when I've selected the plane, selected the object. So it's using some good intelligence there. Just checking my behavior direction, and then I can hit spacebar to repeat, select the plane. It's already selected the solid, and then again, there you go. And what I can then do, I'm just going to select all of those, turn off the visibility, and all of a sudden we're left with the retro reflective prism in all its glory. Now, I broke one of the cardinal rules of CAD. I did not save when I started drawing, so no auto saves would have been done. So I'm going to do a save now. Give the coding, it's just so I know what it is and where it goes. So this is my 10th personal project, part 1, and I'm going to call this prism. And that's the prism essentially complete. And from here, I could, of course, go into change the visual style, throw on some sexy reflections and shadows, and then start doing a ray trace, which I might do with the final assembly. But let's leave this here for now and have a look at the main body. So in Adam's replica, he used a 6-inch half cake mold with a 4.5-inch pipe trimmed to it and a 1/2-inch bevel. So in this case, because we're 3D printing, we could do them as two separate parts to stay true to Adam's method. But I kind of want to show the process of developing that into one unibody as if it was a fabricated. Well, I suppose if it was fabricated, it'd still be two parts. But because we're using additive manufacturing, why not? Let's take advantage of it. So let's have a look at the drawing. Once again, I'm in the same project and I'm going to start with a part file. So just wait for this to load up. Adam used a 6-inch sphere half, which I've converted roughly to 152.5 mil. He says roughly. I'm going to start in the XY plane, so I'm in the front elevation as such. And I'm going to start by drawing a full circle at 152.5. Just referring to my iPad as I look down, just because I've got some notes in front of me, so don't worry too much. I can't remember it all, so it's all good. So I'm going to go with a thickness of roughly 2 millimeters. The reason being, I'm going to 3D print this. 1 millimeter could print and would be fine. I just want it to be slightly more robust, so I'm going to go with 2 millimeters. I'm going to take a line from our origin point and draw that straight up, and I'm going to split that and turn the internal line into a construction and center line, and then leave this one as a solid line. This will become apparent because my plan is to create a profile which I'll then revolve to create our dome and then our connecting body. The next component which Adam connected was a 1/2 inch of the 4.5-inch tube. Now to get this, I'm going to draw a line straight down, and I'm going to make it 15 mil. I'm going to break away from the 1/2 inch just to be different, and I'm going to do 50 mil there. Now we can see it's not constrained, so what I'm going to do now is then give it a dimension from this center line. Now because I've indicated that this line is a center line, you can see the dimensions treating it as such, and because this was 4.5-inch tube, I'm estimating that around 114, or let's go 115 just to be different. That's constrained the line to this point of the circle, and I know it's 115. Now, because we're revolving this, I only need 1/2. So next step for me is to create the interior of this dropping flange. So I'm going to do 2 mil. And then I'm going to trim away this component and this component. So this, if I were to hatch this, this would be the component I want. What I do need to do is just put a little connecting line here, which is covered by the dimension, just to make sure I get a full profile. I'm then going to use the split tool again, and as you can see, it's automatically detected where I want to split it. I'm going to highlight those two lines. It hasn't split this one, so I need to split the inner. And there you go. If I can select those two, I can then put those in construction. And there you go. I get my profile. Now, having sat and thought about this for a little while, I'm thinking about the holes which I need to produce to create the holes for the prisms. Now, if I create a dome and take a hole straight up and through, the hole produced in the radial surface will be oval. So I can't just do a planar series of holes and drill up. It would be like Adam taking it to a pillar drill and just moving it to the right. You'd end up with a weird oval hole over the radial. But in his case, because it's real material, it would buckle and do all weird things. What I'm going to do, I'm going to actually place points along the radial distance and then create planes perpendicular to that point on the radial arc, and then make holes. So let's just jump back into CAD, and hopefully this will become clearer. So I'm going to use the formatting in Inventor. So I'm going to use some color. I'm going to put this into cyan, and I'm going to draw that first circle that Adam drew, which was a 3/4 of an inch, so roughly 18 mil. And I'm going to turn that into line. There you go. Now I've got the format. So that's just because I want that to be referenced, and I want to be clear on what's different. I'm going to make sure I've constrained to the arc again, and I'm going to do my 26 mil. I'm doing 26 mil because I want a slightly different. I want the 3D print that I produced to drop in and the O-ring that around it to do the work. So I'm going to do 26 mil, and then I'm going to tangentially constrain that to this circle, and it's also constrained to this arc, so I know it's perfectly in place of where I want it to be. What I'm going to do, at the center of that, I'm going to place a point. and I'm going to put that into a construction as well, because these aren't things that I want to revolve or extrude. These are just for reference, but the point is the crucial thing that I need. I'm going to finish this sketch, and then I am going to revolve the profile as normal. What I'm then going to do is make this sketch visible, so we can see just barely. Cyan's possibly not the best choice of color, and I doubt it's going to show up in the video. So let's change the color of these to something slightly more visible so you can see where I'm going. So let's go with red. It always goes down nicely. So hopefully you can see that red line there. So my point is just here. So to create my holes, what I'm going to do is create a plane on that point perpendicular to that surface. So you can see that sits perpendicular 90 degrees to that surface. And what I then need to do is start a sketch on that plane, which the computer will take care of me. And then I am going to do 26. Now what I'm going to do, I'm just going to jump back into sketch 1, which is this master sketch. And I'm going to grab, so it's D6. So this is where the equation base of Inventor comes in. I'm going to link this by going D6 here. So if I ever adapt this size, so if I make that 10 mil, in theory, when I update, that circle jumps too. I'm going to go back to 26. There we go, 26. I'm then going to essentially extrude this to cut through. Now the reason I'm not using the hole command for this is what I'm going to do, I'm going to create that, and it looks a bit of a mess at the minute. So what I'm going to do, I'm just going to remove the visibility of the primary sketch, and I'm going to remove that work plane. So I've just ended up with that hole. I'm going to actually circular array this feature, but before I do that, I must remember to create a central axis similar to our prism, and then I'm going to take that extrusion, circular array that around this axis. We're going to produce 4, and that's the first 4 holes created. Now for the next segment, if we consider, if I snap to the top, you can see that we're in this kind of plus sign orientation. I need the next hole to be at 45 degrees. So what I'm going to do is create a work plane at 45 degrees to one of the existing origin planes. So if this is the front, I'm going to take the XY plane, I'm going to do a plane on the axis, and I'm going to do it at 45 degrees. So you can see there, it's 45 degrees. And then it's at this point, what I can do is then start another sketch. Make sure I turn that slice graphics on, so then I get this nice affair, and I'm going to project some existing geometry. So that's automatically gone into red because we've set it to do so, but I'm going to set that back to normal. I'm going to put that in construction, and again I'm going to draw, and I reckon it's going to be D5 because that was the last circle's draw, so that's 18, perfect. And then what I'm going to do is also draw D6 because the hole is the same size. That's incorrect, that's not D6, that's going to be another dimension. So I'm just going to type that's 30 for now. And what I'm going to do again is tangentially constrain to there, and it's constrained to the arc. These again are both construction references, and I'm going to be using the point tool again to get a point of my, just being careful not to pick up any other geometry. What I now need to do, I've actually got 2 really useful circles, and this is quite useful why I've selected. The distance from center of both of these circles will be equal to the distance of the center point of this triangle, because when you do this, it's an equilateral triangle, as Adam explained. So what I'm going to do a dimension from this circle to this circle center, which is showing as 29.517. I now make those construction. What I'm going to do, I'm going to link that to that dimension, and then I'm going to hit finish sketch. And where I've put the point is incorrect, so I've got to remember this. So I actually need to put the point at the end of the circle, not at the middle. That's my blonde moment, so I can get rid of that point, though I didn't really have to, I just did, because that's the, remember I'm doing the diameter, so that is equal to the center of that circle to the center of this circle. Again, I'm going to go through the same process. I'm going to do a plane perpendicular to that surface, and I'm going to start another sketch on this plane, another circle, and that's going to be D6, I think, from memory. D6, lovely. And then I'm going to finish that sketch, and I'm going to extrude, patting, and then I'm once again going to do a circular array around this central axis, and there's going to be 4. And then I end up with something looking slightly like this. Oh, this is nice. Now, what I am noticing just straight off the bat is this gap here between these is slightly bigger than this gap here. So this is where I could then begin to go and adjust using the power of parametrics to shimmy out to try and even that out a bit. So a bit of artistic license here. So that's +2 mil, +3 mil. I'm going slightly off the equilateral triangle thing. So what I should do is just quickly reference to how Adam's look. So I want to make this kind of triangle equal. So I'm just going to escape this, jump back to my model, and then quickly hover around. And I think that's pretty good. Let's just have a quick see if I can get a measure of between 28.589 to 28.58519. So let's do some maths here. So that's the only one that's out. So 30.336 minus, and of course I can't remember the other number because who does, minus 28.519, and that's a difference of 1817. So I like having a calculator next to me. So I'm going to change that to +4. 0.817, and then by the power, and then I know that that should all equal, hopefully, all being well. Let's find out. 30.36, 30.863, 63 minus, that's about 0.5 of a mil at the minute. So let's take that to 317, see if that gets us where our badger is. This is what I love about Inventor. I can keep tweaking and just adjusting. 336, because we know that one. 44, so I'm about 443. So I'll have 1.107. Now I could just let this go. Minus 317, 210. Yeah. 200, 0.1 of a millimeter. Is it that huge a difference? Probably not. I probably won't go beyond this. But you get the idea. 353, 336. Yeah, I'm going to let that fly. And what I'm going to do, I'm going to clean this up by removing the visibility. Get rid of this sketch. Now I could tidy up this model a bit, and I probably will, just for future. And I haven't assigned a material yet, so let's assign aluminium. And then I'm going to save this, because I haven't even hit save yet. God, I'm living on the edge. One of my biggest things when I'm teaching CAD to people, or anyone who's learning CAD, hopefully not from this, because this is me learning at the same time, save first. Oh my God, save first, because you get the auto save, and then if you draw something, you don't accidentally risk losing everything, which is horrific. So I'm going to call this unibody. There you go. And so that is lovely. So the next step we need to go into is to look at the main assembly. So let's place the unibody component, and then I'm going to place that grounded at origin because that's my fixed component, and I'm going to place a prism. I'm not worried about the orientation at this point. I'm just going to place that there like that for now. And I'm then going to go into our content center, because content center with Inventor's got quite a lot of standard components. I'm just going to pick a generic O-ring of the right size. What do we got? 25, I reckon. Inside diameter is what I'm looking for. Diameter 25.8, 25. Let's go 25 because they always stretch a little bit, and the outside diameter of let's go 30.3 because we don't need a really thick. We'll change it later. So let's constrain this and let's get that on there. I'm going to not give it a direction, and then what I'm going to do is use the tangent to then get the radial surface flush with the top of this. So then that sits like so. What I'm then going to do, because I've created that component, I'm going to copy these because then that constraint goes with it. We need 8 of 4, 5, 6, 7, 8. No, in fact, I'm not going to do it that way. I'm not going to do it. I'm going to create 2. So what I'm going to do, I'm going to use the same thing before. I'm going to use a circular array because there's no reason not to use a circular array. Once I've got one in the right position, why do I need to matter? I'm then going to pick the axis. Perfect. Again, I'm just going to set that to be unified direction because I'm going to use the tangential constraint on this again to get onto this surface. Oh, yes, that's so pleasing. After thinking about how to model these circles so they don't turn into ovals. In fact, I don't want to place that one there. I want to constrain this into here, other direction, and then, oh, didn't switch direction. See, this is where I need to be slightly careful and not get cocky. Let's go like so. So, and then I'm going to, so what you probably noticed that I flipped it using the tool, constraining tool, and then set it to whichever direction. That's purely because personal preference. Just I found in the past I normally get some errors if I don't do it like that. And then what I'm going to do is use the circular array pattern, and then I'm going to do it around our existing 90 degrees. And what I can also, oh, I wonder if I can. Yes, and there it is. And what I'm going to do is go to view, turn off all the work surfaces, and there it is, ladies and gentlemen. That is the NASA Retro Reflector Inventor style, and the underneath looks amazing. So let's stick on some shadows and reflections just to make it a bit more fancy. And what I might do is just end this video with quickly doing a ray trace of this in something like this, which will make a nice thumbnail. And then the next step is to export to STL. So thank you for joining me on this little project. It's been a lot of fun and quite challenging for me, certainly to be using the planes and surfaces and thinking about how to create holes on a radial surface. Definitely learned something here. I'm going to 3D print this, and I might make a part 2 on how this prints and do a time lapse and then the assembly, and then we can have a look at how it compares to what Adam built. And thank you, Adam, for the inspiration. At this time it's been really hard to find stuff to do, so watching your project has definitely given me a challenge, and it's got me thinking about CAD again and excited about learning stuff.